So the zombies take over right here. In other words, the zombies are more than the vaccines, and it happens right there. And then if you look at the graph, the point that I'm trying to make here is that this exponential function, because it's a curve, it's always going to take over. It doesn't matter how fast you produce the vaccines. If they continue doubling, there's always going to be a point where the zombies take over, because exponential functions are always faster than linear functions eventually. Okay, so we've learned something about exponential functions here. So it'll happen on feeding 16, the zombies will take over. And the reason why is because no matter how fast the rate is of a linear function, the exponential function's rate is eventually going to be faster. And this should have been linear. So that's really the point that I wanted to make about exponential functions. Things that grow exponentially, people are very bad about making predictions, and it affects their real life. So if you're expecting something to change a little bit and it winds up changing faster than you thought, that's probably because it's exponential. Okay, so let's look at some of the features of these things. A linear function is y equals mx plus b, where m is known as the slope, and the other parameter is b is the y-intercept. So we spent a lot of time writing functions that were linear, and we wrote them in this form, mx plus b, and we found that m was the slope and b was the y-intercept. Okay, and linear functions feature a constant rate, which means that they add the same amount each time, In other words, they add the same, y adds the same amount each time x increases by 1. And then the next one, I can't think when there's so many people interrupting me. Oh, right. When you're reading a word problem, it makes a straight line. The graph makes a straight line. That's how you can tell. Okay, so it has, in the data table, it has a constant rate, which means it adds the same amount each time. The graph makes a straight line. And in a word problem, you're looking for the keywords each, every, or per. Now, this is not 100% reliable. So this is just a good idea to look for each, every, or per. But a lot of the times, like if you make $5 each week, it means that you're going 5, 10, 15, 20. So that if I said I was making $5 each week, then it would probably be a constant rate. So each, every, and per, if you see those words, it's probably a linear function. Linear functions in a paragraph, each, every, or per. The graph is a straight line. The table adds the same amount each time. It's a constant rate. The equation is mx plus b, where m is the slope and b is the y-intercept. Exponential functions, by contrast, have a function of the form a times b to the x, where a is the starting number. For example, a in this case was the number of zombies you had to start with, and b is called the base, or the growth rate. So you remember that we talked about the difference between double zombies and triple zombies? The thing that changed there was the base. Okay? They do not, this has a curved, this is not a constant rate. Exponential functions are not constant rates, which means that it is not a straight line, it's a curvy line. Okay, and exponential functions do not add the same amount each time in the y variable. They multiply y variable by the same. Well, you could have like a common, they have a common multiplier. You want to go back up? Okay. And then, okay, so just to review, exponential functions have a form a times x plus, or a times b to the x, because you're multiplying by the base repeatedly. And let's see, a is the starting number, b is the base or growth rate. That does not have a constant rate because you're timesing the y variable each time. It makes a curved line. And here are the keywords that you're looking for. Every time you have a percent problem, it's probably going to be exponential. And that's because if you make a percent, then you add that percent at the end of the year to how much money you have, and then that grows. So percentages are exponential. If you see the word factor, a factor is another word for a base. So they're trying to tell you what the multiplier is. If you see the words double or triple, double or triple, or quadruple, or something like that. I'm making it bigger. If you see the words double or triple, it is exponential. Okay, so in a word problem, if you see a percent, or the word factor, or double or triple, or anything that tells you that it times is the same amount each time, then in a word problem, that is exponential. The assignment that we're on now is this one down here. Number 2. We just finished the zombie apocalypse spreadsheet, and then the assignment that's good for is right here, understanding linear and exponential functions. All right, so that's this function right here. So let's practice a couple of them. It says, a newborn calf weighs 40 kilograms. Each week, its weight increases by 5%. All right, so now let's look over what keyword we can look for. It's a percent problem, and we know that every time I say percent, it's probably an exponential function. Okay, so is this linear or is this exponential? Well, it's exponential, so it's either this one or this one. And then it's exponential because W increases by a factor of 5. No, it doesn't times by 5, it times by 5%. So that's 105 because that's 5%, so the answer is D. All right, next one. An iceberg floating on the North Pacific Ocean weighs 80 metric tons. Each month, it loses 5 metric tons. So what keyword is there, and is it linear or exponential? Each, and Chris, does that tell you is it linear or is it exponential? No, each is linear because of the keyword each. Each, every, or per is linear. Okay, so I'm looking for linear. It's either this one or this one, and it decreases by 5 because it loses 5 metric tons of weight. So it decreases by 5, so that's the correct answer there. Let me see if I can find one that has the tiles. Yeah, okay. This is, Fidel has a rare coin. What is the keyword and what does it tell you? Nadia, go ahead. What do you see that's a keyword here, and what does it tell you? Is it linear or exponential? Okay, what is highlighted, and does that make it linear or exponential? And that is linear or exponential? Exponential. Okay, Uncle bought a car, and each year it decreases by 10,000 pesos. Linear because of each. The number of wild hogs increases by a factor of 3. So this word factor means multiplier. No. Exponential. Factor means multiplier. Exponential. And you work as a waiter and you earn $50 every day. Linear. Okay? So if you would please, I'd like you to practice that assignment. It's in the middle of the page.